Hello, everybody. Good afternoon and good morning, depending on wherever you are in the U.S. or abroad. Thank you all so much for joining us today. We truly appreciate and value your time. I am Julie Connors. I handle sales for Linear Acoustic in the U.S. and Canada. I specialize in universities and sports, so that is why I wanted to organize this webinar today. Over the past year, I have been talking with many of you and have found that there is a big interest in loudness control and measurement. I reached out to Larry Schindel, Linear Acoustic's Director of Technology, and asked him if he would join me for this webinar. So I'm so thankful he's here to talk with you today. I just wanted to give you a little background on Larry. Larry came to Linear Acoustic from Dolby Laboratories, where he spent 15 years working with professional broadcast manufacturers, consumer electronics manufacturers, and broadcasters themselves, helping them to deploy new Dolby technologies. At Linear Acoustic, he is responsible for defining and guiding the development of multi-channel loudness control, 5.1 channel upmixing, and metering equipment for digital television broadcasters, among many other things we make him do, like webinars. He is a member of AES, SMPTE, and SBE. He also sits on the Industry Advisory Board for RIT, where he graduated from. While working for the CBS television network, he was part of the team which was recognized with an Emmy Award for their work on the 1998 Winter Olympic broadcast from Nagano, Japan. And earlier this year, we sent Larry over to Sochi, Russia to assist broadcasters with the use of our new UpMax V4 unit and other products that handle their surround sound control. So that's just a little background on me and Larry, but I did want to tell you a little bit about Linear Acoustic. We've been doing DTV audio for over 10 years. We were founded in 2002 by Tim Carroll, who also formerly came from Dolby Laboratories, and we're known globally for our audio processing, specifically our Aeromax. That is our loudness processing engine, a part of our entire Aero line, which is found online. We also are known for our UpMax technologies. The Telos Alliance was formed in 2008, which includes Telos, Omnia, Axia, Linear Acoustic, and 25/7, so we're able to provide an end-to-end broadcast solution for television and radio. And we were very proud to receive a technical Emmy in 2010, and we have been supporting the Olympics with upmixing and loudness metering since Beijing back in 2008. So that's just a little background on Linear Acoustic. I guess we can dive into the next part of our webinar here. Take it away, Larry.
Today, we'd like to go through a few things. Start with the loudness regulations, U.S.-centric focus here. Although loudness regulations are spreading around the world, we'll go through some loudness measurement, loudness control, and some practical usage. So let's start with loudness regulations. Here in the U.S., the loudness regulation is called CALM. So what is the CALM legislation? Well, CALM stands for Commercial Audio Loudness Mitigation. And this is legislation that was passed back in 2010. It was passed on actually September 29th of 2010. U.S. Representative Anna Eshoo from California and U.S. Senator Whitehouse were the two that led the charge on this legislation. What this requires is that commercials on TV being broadcast are not louder than the program that is surrounding that. So the legislation was passed in September 2010. It took the FCC a little over a year to write up their rules and regulations on that, which they published in December of 2011. They gave broadcasters 1 year to get ready because the regulations were going to start to be enforced in December of 2012. As part of this regulation, this applies to really all commercial broadcasting, whether it's over-the-air, terrestrial DTV, cable providers, satellite providers. It really applies to them. And the way the legislation is written, it's whoever touches the commercial last is the person who is ultimately responsible for making sure it's compliant. Now, as is typical in business and carriage negotiations, many times the cable broadcasters or satellite broadcasters will push back on the content providers, making the content provider responsible for delivering compliant material, be it an ad spot or programming. Many of these operators do not want to install processing on the literally hundreds of channels that they turn around simultaneously. On the technical side, the technical documentation called out by the FCC is the ATSC A85 specification. This specifies a target loudness value of -24 LKFS. And a little bit later, we'll get into what LKFS means. Really, it means the average program loudness should be -24 dB full scale. There is anticipation of some minor variations in this, so there's a tolerance window of plus or minus 2 dB. As part of this minus 24 dB LKFS measurement, ATSC A85 calls out an anchor element for long-term content. And really what is meant by long-term content is anything that's greater than about 2 minutes in length. And the anchor element is really defined as what element of the mix they will adjust the volume control on their TV set or home theater receiver to when they're adjusting that. Typically that's dialogue. So for long-term content, really the most accurate way to measure is tuning into the dialogue and building your mix around that. There's also another type of measurement, and it's called true peak. True peak is part of the loudness measurement standard that we'll get into. And really it's interpolation between the 48 kilohertz audio samples just to make sure that there could not be any peaks in between there due to aliasing. And within A85, they specify the true peak value to stay under minus 2 dB. True peak, which would be relative to full scale. And this is to prevent clipping and overload from happening further down through the chain. Now, I recommend that everybody go and get the standard. It's freely available, the A85 spec, on the ATSC website. The link is shown below, but it's really easy to remember, www.atsc.org. So what has changed since CALM went into effect? Well, there's some good, there's some bad, and there's some ugly, or upcoming ugly. The good news is that content is being delivered more consistently. And this is applying to not only the commercials, which again, the CALM legislation strictly references commercials not being louder than the surrounding program, but content producers are also producing broadcast the program material, typically at minus 24 LKFS, which is ideal. Now everything should match as it's being broadcast at the end result. The bad news is there's still not as much consistency as some people would like, and there's still a lot of confusion in the industry. The rules here, the legislation and A85 and the other specifications around the world, they're meant to measure the entire length of the program and to provide increased consistency across programs, program segments, in between channels, and across commercial. But what's happening is a lot of people in broadcasters are getting confused, and they want that loudness meter to stay at minus 24 LKFS all the time, much like an old analog modulation meter might be. The result of this is really unnatural sounding audio, and it's extremely compressed, and you can hear that. So the meter should be able to move some. We're looking at the overall length of the program is what we really want to focus on. It's good to have dynamics in your mix. You want those to stay there. It makes it sound far more natural. The ugly, or the upcoming ugly, is mobile devices. Mobile devices are going to add another layer of complexity to this whole issue, not only from loudness issues, but from intelligibility. If you think about listening to a hockey game on an iPad or your iPhone, or even watching it on your laptop or computer, that audio and those little speakers, it's a lot harder to discern the announcer and the dialogue when there's a lot of crowd noise than it is with a television or even home theater system. So this is something to keep in mind if you're doing a lot of mobile streams. You may want to process not only loudness but intelligibility separately and make that a separate output. The FCC has been keeping statistics since CALM became effective, and they're reporting these on a quarterly basis to Representative Eshoo and Senator Whitehouse. I have the latest statistics, which just came out not too long ago. It's all in this graph, but there's a lot of data here. So let's look at this actually in a graph. It'll be a little easier to see. So looking at the far left side, CALM became effective in the middle of December in 2012. The blue line is the total number of complaints that the FCC receives. The red line is how many that they determine to be valid enough to pass on to the Enforcement Bureau. Before the legislation was enforced, October, November, and the first half of December 2012, there's very few complaints. They existed. It's still one of the most complained about things with the FCC, but the numbers were pretty low compared to the last half of December and then January. But this is natural, and this is because all the broadcasters were promoting the fact that there's new legislation mandating the commercials are not louder than a program, and you can now complain to the FCC on that and something will be done. So that's natural, and we see a natural decay on this down to it's almost a flatline, consistent number of complaints. There's a slight dip in October of 2013, That was because of the government shutdown. There's partial reports for that month. And a few months ago, back in around March, the FCC updated the reporting template and form that consumers use to report. So now they're actually sending more and more of these complaints are being viewed as valid and are being sent to the Enforcement Bureau. And it's about 99% the last month that we have statistics on. Now we want to figure out how to measure and make sure that we're compliant. So how do we get into this whole mess to begin with? If you look back at analog TV, the audio was delivered by FM, just like FM radio. So the frequency response was 50 hertz to 15 kilohertz. Theoretical 60 dB dynamic range, but about 50 in practice. The audio was just mono or stereo. Once we moved into the digital realm, now we have full frequency response. We have much, much greater dynamic range available to us. And in fact, with the digital audio systems today, it's perceived to have 32 times more dynamic range than with the old analog ATSC system. Also, our audio can be mono, it can be stereo, or it can be 5.1, and in the future, perhaps even more channels than 5.1. But to meter all this, the metering started as first a VU meter and then the peak program meter. And these were electrical measurements, which is very much necessary. You need to know what level the signal is at, especially in the analog domain, where you need to make sure you're not going to overdrive or clip downstream devices. So to keep your audio nice and clean that way. But this is not how we hear loudness. Loudness is very subjective, and there's science that backs this up. If we go back to 1933, Fletcher and Munson released a paper, and they came up with what is called the equal loudness curves. This shows our hearing is very nonlinear. And if you look at the graph, you can see that we are far less sensitive to low frequency sounds than we are to higher frequency sound. And we are most sensitive to sounds around the 3 to 4 kilohertz range. So stop and think about this. If we are using an electrical level meter, the level that it shows at plus 4 VU, or in today's world, minus 20 dBFS, if that's a 200 hertz tone and it's a 4 kilohertz tone, they'll show exactly the same on that level meter, but they're going to be perceived as being different loudness to us when we listen to them. Additionally, not only is our hearing nonlinear in the frequency realm, but also across the level realm. So it's kind of a sliding window as far as something may sound louder at one listening level than another. So we really needed a way to measure or come up with a way to emulate and meter how we perceive things to be loud, because pure electrical meters just were not cutting it. So this was actually an international undertaking, and the ITU, which is the International Telecommunications Union, came out with a standard called the BS 1770 standard. And all the international loudness regulations and standards are built on BS 1770, whether it's here in the US, whether it's Europe, Australia, Japan, and many other countries around the world. With BS 1770, this actually uses filtering to account for the effects of our head and really to try to emulate how it is that we hear. It's designed to replicate the human auditory system. And currently, this is the most accurate way to assign an objective numeric value to our very subjective hearing with signal content. It uses a K-weighting filter, as you can see in the graph, and the letter K really has no meaning. But this translates into, when we say LKFS, that unit means loudness, K-weighted, relative to full scale. And that's calibrated in dB. If you're looking with European standards that follow R128, they'll call it LUFS. It's really exactly the same thing. They just change it from loudness K-weighted to loudness unit. So that's all the differences between LKFS and LUFS. And as I mentioned previously, true peak is a measurement that's in here as well. So the loudness measurement standard, the BS 1770, was first released in 2006, and there's been a few updates to it since then. We're currently on 1770-3, which came out in 2012. 1770-2 added relative gated measurements, which makes the whole tuning in on your anchor element a little bit easier with long term. What's interesting to note is that the -3, the last update, simply removed a filter in the true peak section that was optional. So if you already have 1770-2 meter, it's going to be compliant with 1770-3. You don't have to worry about that. Now that we know what those units mean, I just want to go back and reiterate quickly what A85 states. And it calls out minus 24 LKFS, which is equivalent to minus 24 dB full scale, as your average loudness for the entire length of the program, be it 40-minute drama, a hockey game, or a 30-second commercial. The meters will display LKFS, and there's also the true peak value in there. So this is loudness measurement. Now that we can measure it, and we have tools to measure it, and we know what to look for, we need to be able to manage and control our loudness to make sure we stay compliant. Not just compliant, but we want to be able to match programming and around your program to keep viewers happy with programming and interstitials and changing between channels. And different viewers have different requirements. If somebody's watching on a TV in a set-top box, they're really interested in the consistency of the loudness, because the little speakers on a television can't reproduce a lot of bass or a lot of loud sounds. Compared to somebody who has a nice home theater that has a subwoofer, a 5-1 setup, they're going to want to have loudness consistency, but they can also deal with the dynamics and want that. They went out and spent the money. They want to be able to hear somebody get checked into the boards during a hockey game. Mobile devices, again, will add some complexity to this going forward, and they will be even more concerned about loudness consistency than even television and set-top box. There was also a lot of research done in something called the comfort zone. And what this is it's the range of how much louder or quieter the sound gets from where you set the volume control, when you set the volume control, to where you'll grab the remote and turn it down. So if 0 is where you have adjusted the volume control to with whatever content you're listening to, on average, you will accept program going louder by about 2.5 dB, and we're talking average level, not an explosion in a action movie. You'll be tolerant to that, to about 2.5 dB, before you'll grab the remote to start turning it down. And similarly, when things get quieter, by about 5.5 dB is where people tend to reach for the remote to turn it up. That's about an 8 dB window, called the comfort zone. Outside of that, it's about a 16 dB range where you'll grab the remote and turn it up or down, but it's not annoyingly loud, where you would have to jump for the remote. If you notice, this range is not symmetrical. You're far more sensitive to sounds getting louder than you are them getting quieter. So here's a look at some loudness of audio that was recorded, and you can see that the green is audio that's about in the comfort zone. This is actually about a 12 dB window, slightly narrower than the 16 of where you would adjust things. But you see a peak of where it is too loud. And then there's also segments where the loudness, it's too low, the blue segments. With loudness control, what we try to do is we try to bring this all into the tolerable window within the comfort zone. We try to get most of the audio within the comfort zone based on this. So real time, it does offer some dynamic range. You do lose some dynamic range a little bit. But again, if you think back to the TV and set-top box, that's actually desirable for them. And there are ways within the Dolby encoder that people with a nice home theater system, they can actually turn off a lot of the reversible dynamic range compression that happens there. Now, there's always some debate between wideband and multiband. Each has its own merits and best uses, but we believe using a mix of both really provides the most natural sounding audio while still maintaining calm compliance. And we actually have a white paper up on our website about this, which you can download for free. Looking at some of our processing, it'll start with a wideband AGC, and then from there it moves into multiband, where we divide the audio up into different chunks of spectrum and process those individually, and including an AGC and a limiter, we combine them back into a single mix with a final limiter. And these go in order from slowest to fastest, where the AGC, the wideband AGC at the beginning moves very slowly to catch trends. The multiband processing is very good when you divide up the audio spectrum. If you think of somebody crashing into the boards at a hockey game, there's a lot of low frequency information there. So using multiband processing, we can actually control that part of the spectrum, and you can still hear the announcer after that calling out the name of the player who was shoved into the boards. With strictly wideband processing, what would happen is it adjusts all frequency components the same. So when that player gets slammed into the boards, your AGC will grab that and reduce the level of the entire mix down. And then the effect of that is you cannot hear the announcer while the gain is being reduced. So using multi-band processing helps this a lot. And by using a combination of the two, you really get a natural sound whilst maintaining good compliance. Now I want to talk a little bit about file-based loudness processing as well. File-based processors offer some real advantages over the real-time processor. And this is because the entire program is present when it makes the measurement and makes the decisions on how to process. So the loudness of that one single program can be measured extremely accurately. You know when it starts and when it stops. And they can process that whether or not it needs dynamic range control or simply level adjustment to get to the correct minus 24 dB LKFS for the average. Real-time processors are, no matter who makes them, are always taking a best guess as to whether the dynamics in that they are seeing are intended or if it's a commercial that is out of compliance, where the file-based processing will know this is my piece to process and that the dynamics in there are intentional. So if your workflows allow and you're set up with servers and to do post-production, always the best results will come from file-based control and processing. Okay, so this is all really good information, but what do we do with it? How do we use it? A common type of distribution chain. You can think of this as almost a sports broadcast where you'll have the remote truck or the control room out at the venue creating your program which feeds to your main facility, whether you distribute it in real time or record it on the servers and play it back later or even tape in some cases. From there, the signal gets distributed, many times local on-campus IPTV or closed cable system, or perhaps you distribute it out to some of your local affiliate stations or local cable system for distribution within region. Once it goes to the local station or the cable system, they're required to make sure that your programming and commercials go out at the proper level. And they may push it back onto you to make sure that you're delivering it to them properly. And really, you want to. You don't want them to insert a simple single-banded dumb compressor limiter on your audio and have them squish any dynamic range out of it. If you deliver to them at the correct levels, the end result to all the viewers at home who couldn't get tickets to the game is going to be far better for them. One thing I want to touch on here a little bit is about Dolby Digital. This is the audio format for DTV here in North America. This is what ultimately goes out to the viewers. This is the very same Dolby Digital that is found on DVDs and Blu-ray players and things like that. So this is the set-top box and home theater receivers can decode it. This can contain anywhere from mono up through 5.1 audio. It transmits all channels that are given to it. So if it receives a 5.1 channel stream, that 5.1 channel stream goes out to every home, and the set-top boxes and TVs and home theaters know what to do with it. Even if they only have one or two speakers. There's information in that stream called metadata, which tells the decoders what to do under certain circumstances, how to mix that down. But also, the audio is transmitted with full dynamic range that it was received, which is something to keep in mind. There are a few metadata parameters when configuring an AC3 a Dolby Digital encoder, and I'm not sure if your facility has a Dolby Digital encoder. It could be present in a video multiplexer or a modular frame system or some other piece of device. They're very, very common. But I can assure you that your local affiliates and cable facilities will encode this into Dolby Digital before it goes out to the consumer. There's a few very key parameters in here in the metadata to always pay attention to when you configure the encoder. One is obviously the audio coding mode, and that tells the encoder how many channels of audio it has. Are you sending stereo, or are you sending 5.1 or mono or dual mono? That's a very basic configuration. But the other one is dialogue normalization. This is supposed to match what your average program loudness is coming from you. So if you are mixing to minus 24 LKFS, that dial norm should be set to minus 24. Many people would just not set many of these parameters except for AC mod and data rate and leave the other parameters at their default settings. which may or may not match what you're doing. So it's important to match dial norm to what your output level is. There's also dynamic range compression profiles for line mode and RF mode. And make sure you use these and don't set them to none, because if somebody's listening on a TV, they will want the additional compression that's provided by RF mode. The consumer can always defeat, in a high-end home theater, they can defeat if they want the decoder to perform this additional compression, but it's the encoder that actually creates the gain words to tell the decoder how to process them downstream. So make sure that you use settings for that. So let's talk about all the way from production to transmission, what to do with your signal path. Really, to achieve the best quality audio all the way through the chain is to consider that loudness measurement and management is a system-wide process and not just a unit that's put in directly before transmission. What could happen there is that you're providing a signal that's way too hot. That one last device has to work very hard to keep things compliant, and it'll become audible. So it's always best to view this as a system-wide process. So in production, make sure you have a loudness meter, and you want to use the loudness meter and use that as a speedometer. You want to mix on average towards the comfort zone and that target dial norm value, but you still want to be able to develop a compelling mix and just use, again, using the loudness meter as your speedometer. When you go to ingest content, again, measure, normalize to the dial norm value, try to control the loudness to the comfort zone. And as I stated before, you really want to do this in the file domain if at all possible. That will always provide the best results. If it's not possible, perhaps you can insert a real-time loudness control unit on the front end of your ingest process if you know there's not one further down the chain in your facility. And for transmission, it really comes down to measuring and normalizing to the target value, dial norm, and measuring the program loudness. Here's a list of things not to do. One is not to rely on an unsophisticated wideband or perhaps even analog processor at the end of the transmission chain to squash your audio and force it into compliance. That will not sound natural at all. It will sound very processed, and if you manage it throughout the entire chain, it will sound very natural. You don't want to confuse a happy meter with a happy viewer. Meters will give you the loudness value, but they don't measure the quality of what it sounds like. It's an audio feed. You're supposed to listen and use your ears ultimately. This is what the viewers are doing. Again, the meter should move some from -24 throughout the course of the program. That's natural. That's very good sounding. If it stays locked at -24, odds are you have very bad sounding audio. And don't ignore the problem and hope no one complains. Once they do, it's too late. The FCC is enforcing by complaints. That's typically how the FCC works with everything. So don't ignore the problem. By doing so, the viewers end up aggravated. And we all want happy viewers. You want them to come back. So fidelity and compliance. Realistically, this sums up again that if you produce your audio with good practices, having calm compliant audio is going to sound very natural. And really the goal of having a good viewer experience is not that different from the goals of the calm legislation. We all want the viewers to be happy. And you have to use an audio level meter that is using the BS 1770 standard, where it is a perceptual loudness meter, which meters how loud things actually sound to us, which again is very different than just a pure electrical meter. And again, just remembering, final thoughts, if I can just really hammer this home, is that to treat loudness measurement and control as a process throughout the entire chain and not simply a single box right before the multiplexer. Meter and monitor the whole way and use good practices to keep things about the target levels all the way through the process and maintain intended dynamics. This is a very good thing in your program. That meter should move from -24 as the program is going.
We have some time for questions. Mr. McCall, I'm going to unmute you right here. Javed, you there?
Yeah, just a very quick question. I'd like to know the difference between the dial norm and the COM.
Okay, so COM is actually legislation. It references the ATSC doc to say make your average loudness value of the program at -24 dB full scale, -24 LKFS. Dial norm is actually a metadata parameter in the Dolby Digital bit stream itself that has to be set by the encoder. Those two numbers should match. So your dial norm value of the AC3 stream should match and be set to match what your loudness meter tells you your average program loudness is.
And then in dial norm is that's the process of encoding the metadata within the signal before I transmit. That's what you're trying to say.
It's one of the parameters, one of the fields you can set or that are present in the metadata. That's correct.
We do have another question. Can you use a Dero loudness meter in the production room to reference perceived loudness?
The quick answer to that, the loudness meters based on BS 1770 will actually give you a numeric value. They'll give you a readout like you see here on this slide. So on this slide, if you look at the top graph, there was an ITU LKFS at that moment when I grabbed the screenshot of minus 15 dB, minus 15 LKFS, which means that program was very loud at that moment. So you need to have a meter that is going to give you this numeric value, this LKFS meter. That means it is an ITU BS 1770 compliant meter. The typical Doro meters that I remember would give you a peak and an average level of your mix. That's really just simply a fancy electrical meter. It does not give you how we actually perceive loudness to be and does not give you this reading on a scale like this.
We have another one from Matt Searley. Does the COM Act extend to web streaming and on demand?
I believe not yet. It was primarily focused towards actual traditional broadcasting. This is certainly an area of things that are emerging. It's a bit of the Wild West out there yet. And actually the target values that you want for a web streaming service or a mobile service, as we call it, is going to be actually different levels. It's not going to be the minus 24. We're seeing most content in music and things like that really running around minus 14 for this. So that's why I'm saying processing and level control is going to be a bit different for those mobile type streams than for traditional broadcast.
We have one from Todd Jones. Is LKFS and dial norm, do they apply to down converted SD?
Yes, they do. Anything that is digital audio, they will, as far as broadcast goes. Now, there can be a little bit of a buildup when you down mix from 5.1 to 2-channel stream. So I would always recommend metering that as well. In the BS 1770, in the measurement, all the channels, except for the LFE, are weighted and measured. LFE is not included. That is, LFE stands for low frequency effects. And that's supposed to be just an effects channel for when there's explosions and things like that in a movie. That's why that's not included, as well as our hearing is not as sensitive to those low frequency sounds. The 5 full range channels will get measured when you're doing a loudness measurement, and the surround channels are actually weighted slightly higher in that measurement than the front channels. This is because of the effects of how your head blocks sound is the reason the surrounds are measured slightly louder. It is possible to see a slight difference when you measure a down mix from a 5.1 and the 5.1 itself. But ultimately, give it a listen. It should not sound louder, where the meter can be tricked a little bit. Really, at the end of the day, the viewers don't have meters. They only have their ears to go by. So I encourage always, always, always listen.
And we had a follow-up question from Matt. He said, I have noticed that a lot of traditional broadcast organizations and high-end streaming services keep to a standard that is close to minus 24. But with YouTube, music, and other user-generated sites, it's the Wild West.
Absolutely. I mean, if you look at companies like HBO and ESPN that are doing a lot of web streaming, they will be pretty consistent. But YouTube and stuff like that, it is the Wild West, and there's no regulations there yet. As a lot of the web streaming and mobile services, things take off and become even more popular. Right now, that's all in the infancy of that market at this point. I don't know whether legislation would come out of that, but certainly best practices and a lot of your complaints or consumer complaints will come out of that. And they'll take note that there are people out there doing it properly.
The question was, Larry, what processor or what device would Java need to embed the dial norm metadata into the final HD SDI signal?
So there are a couple ways to do this. If you're carrying the audio as PCM, there are devices in the embedders or outside the embedders that will call what they call SMPTE 2020 metadata. And SMPTE 2020 metadata is the very same Dolby metadata that goes into the Dolby digital encoder. So the Dolby encoder, if it receives the input PCM audio, should be able to accept this metadata from SMPTE 2020 and use that as well. So it's possible if you set the metadata correctly upstream, that the downstream Dolby encoders can accept it. If you are carrying AC3 in your HDSDI stream, which is legal, you can do that. Many people do. It's very, very common. That is set during the encode process. That is one of the parameters on the AC3 encoder itself, the Dolby Digital encoder itself. So whether or not it is set locally when you configure the encoder, or the encoder is set to accept an external metadata source from SMPTE 2020. It's going to kind of depend on your workflow.
Go ahead, Javed.
Yeah, I think being new in this area, my question is that in any average broadcast facility, or all mixing boards and everything, before we sending the final signals, when the audio video get embedded at the video switcher part, we are sending, for example, a 0 dB, because all the mixing boards set up at +4. All audio signal are going at +4 dB, which is set to 0 reference of the analog, or at full scale 0 dB. So from there, my signal is going as a standard audio -10 dB, non-compressed or non-limited, anything like this. So if I put any audio processor device right after the mixing board with a multi-band compression or whatever it is, that device only is going to process the audio. It's not going to enter the data saying, okay, this the final output is set to present -24 dB. So this is my data sending at it. My question is, which I'm trying to understand, how do I collect that, create that metadata to put it in there, that what is my signal is, which I'm sending at it. Thanks.
I see what you're saying. What I would recommend is that you have a loudness meter that can measure it in the HDSDI stream, and in your A to D conversion process, you should be able to scale the level of when you send out your reference tone out of your analog mixer into the analog to digital converter. You can adjust that to be, it's typically -20. You could set that -24, but still use the loudness LKFS meter on the mix, and they can monitor that from the HDSDI stream. And once you get a pretty good reference level set, as long as they mix around that and to that, you'll be fine.
I guess my understanding of -24 is -24 is not how should I say? It's -24 is calculated over a certain time periods, averaged out a set time periods.
That's
out
right.
there. It means my setting of a -24 at the meter level does not really representing the -24 over the average time period spans. So I can set up, for example, my meters at the say a -15 or -10. It will still probably, because of the dynamic range coming in there, might average out to -24 at the end. So how do question mine is that how do I set my meters? So basically what you're trying to say, what I'm trying to understand, is that I can play around with my meters until my the 770 meter or 1770 meter is showing me my -24 average. So moment I get that, I'm saying that I can pretty much sure that my settings, whatever settings are at the analog console or digital console, are now meeting a -24 settings. Is that correct?
Yeah, that sounds correct. Once you get that gain structure and conversion from analog into digital correct, I would use a piece that's dialogue and narration to configure that, not something that's going to have a lot of different type of program content and dynamic range. But once you get that things calibrated and set, you'll be pretty close as long as your mixer is consistent.
It's from Oscar Enriquez. He said, could you tell me how the FCC controls stations that are actually transmitting at the right levels?
Basically, the enforcement is done when they receive enough complaints. There are a few entities that they have been investigating that have been consistently out of compliance. Since it's an ongoing investigation, they won't say who at this point, but they are investigating a few entities that are consistently out of compliance. The goal here is to be consistent, or a consistent trend. If you have one commercial that is out of compliance and it airs once, there may be a complaint, but the FCC is really looking for trends, not one single complaint.
And what's good is that if you do have a product that does do your logging, say you do get you know, some kind of complaint and someone contacts you to provide, you know, background, that consistency that Larry was talking about can be documented through a log. So it's kind of nice to have that as like a backup, just in case, you know, you get someone knocking on your door asking for, you know, your logs for the past 48 hours or what have you.
Yeah, and most broadcasters are doing logs. If you remember that slide I showed you that had the audio in and out of the comfort zone window, that was actually, that graph was made from Loudness logs and was simply graphed in Excel. So logging and keeping records of data is very common practice by broadcasters for just in case the FCC does come knocking at the door or if a viewer calls and complains.
We have another question here from DJ. On our college campus, their student-produced campus cable TV operation occasionally asks the radio station to produce audio for program openings and closing, promotions, PSAs, that sort of thing. But all our radio production equipment is VU meter based. What would you recommend for audio levels processing for those TV audio pieces?
Well, if you have the pieces in advance, I would recommend measuring them in a file-based domain and scaling them appropriately, if that's a possibility. Many of the audio editing tools either come with an LKFS meter or it's a plugin that you can get. Otherwise, you know what your program loudness is going to be, or your mix should be about, and just listen to it and get it close to that range ahead of time.
Scott, can you hear us okay?
I'm here.
Okay, what did you mean?
Yes, I can hear you. Can you hear me? I was talking about the same thing of if our radio department cuts a spot, you know, how, what level should they record it at according to their VU meters on their mixer?
Yeah, see, looking at a VU meter, it's really difficult to equate that to an LKFS, an actual loudness measurement reading, until you've been using that same system on that same calibration for a long time. So I would recommend some sort of loudness metering in that case and measure that spot for actual loudness, not just electrical signal levels.
And then Javed had a follow-up question. Does this compliance also apply to FM radio broadcast?
It does not. This is strictly TV at this point, though interestingly we are seeing in the radio space that radio broadcasters are actually looking at loudness, this perceptual loudness metering on their own and willingly. So we're starting to see some people do that.
I think one thing I just want to ask you real quick, Larry, just because I've gotten this from a few universities that I've talked to over the past year, is, you know, what happens to the sound if loudness control is left to being part of one box right before, like right at the end, right before the multiplexer? What's the danger or benefit in that?
Well, the danger there is that the audio can end up being transmitted extremely compressed, and that even an untrained listener would notice that the audio is very compressed, and it just does not sound natural or good. I can give you an example. I was watching a broadcast. It was a band called the Australian Pink Floyd. They were playing an intro to one song, and every time the percussion came in, I mean, I could hear the entire level drop and then slowly fade back. So it's things like that are the dangers of not managing this as an actual process. Basically, if you have one box that is working very, very hard, no matter who makes the box or what type it is, it's going to have audible effects on the output audio. Where if you manage it as a process and maybe gentle tweaks along the way, you're going to end up with a much more natural sound, the way the mixer intends it to come across and produce it.
A last question here, which is about logging. How long is it mandatory to keep loudness log records, 30 days or what? And that's kind of an interesting question.
I'm not positive that that logs are mandated.
I don't believe they are. I think it's precautionary.
Yeah.
But it comes, I mean, with our gear, for example, it comes with your processing, so you have that as backup, that safety net. But as far as something in the COM Act saying you need to have a loudness log for 30 days, it does not state that at this time. We thank you so much for coming. Please feel free to email me. Many of you have my email, julie.connors@telosalliance.com. We would be happy to answer any of your questions or arrange a follow-up technical discussion with you if we didn't get to, you know, tackle anything that, you know, you still were wondering about. But thank you all for coming, and thanks, Larry. Great presentation. I really appreciate you going through everything so thoroughly for us.
Oh, thank you, and thanks everybody for your time. We realize it's a really busy time of the season, busy season for you.